Big data with Hadoop. Hadoop is an open source project maintained by the Apache Software Foundation. It was originally created by Doug Cutting. Hadoop is used, it's a software framework for querying and analyzing large data sets that are in the size of multiple terabytes. So we're talking about very large data sets. And the idea with Hadoop is that you can install and run Hadoop in a cluster. So you can create many computers that are all running Hadoop, and they're all work together to, at the same time, in parallel process and parallel store all of the data. This enables you to query and search large amounts of data very quickly. So let's take a look at how Hadoop basically works, a rough overview. So Hadoop has two main components, the storage side and the processing side. The storage side is HDFS, the Hadoop Distributed File System. You've also got Mapreduce, which is for distributed processing. Now, to create a Hadoop cluster, what you need is a master node, and the master node can be one computer that runs the name node, which is for the HDFS distributed storage, and the job tracker, which is the master for the Mapreduce distributing processing. Now, you could also take the master and put them on separate servers. So you could have one server as the name node and another server as the job tracker, or you could use both of them on the same server. You can also have a backup master. Then, besides the master, you now need your slave computers, which are going to do all of the heavy lifting of querying and processing and storing of the data. So the slave computers run two processes to go along with the HDFS and the Mapreduce. They run the data node process and a task tracker process. Now, the data node processes are managed by the name node, which is the HDFS master, and the task tracker processes are managed by the Mapreduce job tracker, also in the master computer. So in this diagram, we've got one master that is the name node and the job tracker, and it manages all of the slaves. Now, with the slave computers, in this diagram, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slaves. And each slave is running two important processes, the data node process and the task tracker process. And it's all being managed by the master node up here. Now, in reality, this would be a very small multi-node Hadoop cluster. A Hadoop cluster could go as big as multiple racks of many slave nodes. We're talking maybe 10, 12, 13, 14 slave nodes per rack, and then multiple racks, 6, 7, 8, 10 racks of servers. So you could have 60 or 70 slave computers or more. You could have 100 slave computers and then the master computers managing it all. In this situation, we just have 10 slaves and one master. So this would be a very small Hadoop multi-node cluster, maybe just for testing purposes or something like that. So let's look at the basic idea of how it works. Let's say that we have a big file. We have a ton of data. We've got this file here, bigfile.txt, and it's thousands, let's say, of terabytes. Let's say it's 100 terabytes or 1,000 terabytes or something like that. So how does Hadoop manage that? How does Hadoop work with large data sets like this? Well, what it does is it breaks the data set into blocks. So you can see here we've partitioned it off and we've created different blocks of data. So we've now got the A block, the B block, the C block. And this is just an example. This is a rough example. So now we've taken our large data file, our large data set, and cut it up into blocks. Now, we're going to apply those data blocks to our Hadoop cluster. So here we are. We have our master name node. This is the node that deals with storage, the Hadoop distributed file system. So at first what we want to do is we want to take our data and we want to distribute it to our slave computers. So how this works is the name node master, which is also the HDFS bookkeeper manages these data nodes, manages the slaves. So it's going to take this big file.txt file, and it's going to distribute the data blocks to the slave nodes. And notice in this case, we've taken the first data block, which is the A data block, and it's been distributed to multiple data nodes. So the replication factor in this case is 3. So the name node distributes the block to multiple servers so as to create redundancy, basically a fail-safe mechanism to fight against loss of data. So block A has been distributed to data node 1, data node 3, and data node 5. Then the B block is distributed to data node 2, 4, and 6, and so on and so forth. We see that the data is distributed, replicated by 3, creating redundant sets of data. If you have the data replicated, if one of these slave nodes was to fail, you'd still have access to your data. This brings up an interesting point. If you have, let's say, 100 terabytes of data, and you're going to replicate it across your slaves with a replication factor of 3, 100 terabytes of data will take 300 terabytes of storage when it's distributed to all of your slave nodes. And in this diagram right now, I've just shown 6 slave nodes. So now, if we look at our slaves, all of the big file data blocks have been distributed to the slaves, and you can see here we have block A, block B, C. All of these blocks now can be accessed and searched or queried, and processes run on them in parallel simultaneously, and that's the power of Hadoop. So when you go to look at your data, you can have, in this case, 6 computers all running their processing simultaneously and in parallel as they access all of these data blocks. This gives you increased power and performance. So now, if we look at an example, we can see here that data node 5 has gone down. So maybe there's a hard disk failure, disk drive failure, and data node 5 goes offline. Maybe the networking leading to data node 5 fails. It could be many different reasons. Even though data node 5 goes down, you can see by the highlighted blue that we still have a block for A and B and E and C and G and D and F. So the replication and the distribution of the data across multiple nodes ensures the redundancy of our data. And now when we replace our disk drive in data node 5, the data can be rebuilt from other nodes. And this is all going to be handled by the name node that manages it all. It has a metadata map and knows exactly where all of the data blocks are located, and therefore can rebuild the data. Now let's look at the Mapreduce, the job tracker portion. The job tracker manages the parallel processing in the task trackers and manages the Mapreduce jobs. So in this case now we've moved over to the processing part of Hadoop. Now in this case, let's take an example. Let's take the example that each of our data blocks contains a set of sample data. So there's still block A, B, C, D, and so on. And in each block we have this sample data. In this case, it's just some letters. We have a set of 4 letters in each of our data blocks. So this is how it would be distributed across the slaves. The Mapreduce job in this example is to count the letters, or as you would find in many of the Hadoop tutorials, a word count job. In this case, we're counting letters though. So the job is to count the number of letters in bigdata.txt. So the job tracker will now assign the data processing jobs to the slave nodes, to the task tracker nodes. And the job tracker is also going to account for redundant data. So it assigns the jobs to a block A, and it assigns another job to block E, and here is block B. So those task tracker nodes will run the query or run the process or the program, and in this case it's counting the letter count. And you can see that we're tallying the letter count in task tracker 1, 2, 3, 4, 5, and 6. Once the task trackers are finished, they will send their results to a reducer node that has been set up by the job tracker. In this case, task tracker 2 is now the reducing node, and it will collate basically all of that data, finish putting the data together, and then send the data, output the data to the big data output into the HDFS system. So it'll go back to the name node and finally to the client that's requested this query or this job. And now the Hadoop cluster waits for its next task or job.